TK4830 Portable Tester for AC and DC EV Chargers Operation video. Thank you for using the TUNKIA TK4830 Portable Tester for AC and DC EV Chargers. The following video consists of 4 parts. 1. Product Introduction. The TK4830 is a portable tester for AC and DC EV chargers, supporting the European CCS2 DC interface and Type 2 AC interface. With an accuracy class of 0.1 for both AC and DC energy measurement, it performs operate error and clock indication error tests for AC/DC chargers. The TK4830 allows testing using either an electric vehicle or resistive load as the load. Combined with wide dynamic range measurement technology and millisecond-level high-speed energy refresh, it enables precise cumulative energy measurement throughout the entire charging process. 2. Accessories and panel. Check the packing list to ensure all the accessories are complete. Front panel. 3. Interface. DC and AC switching. Frequency. Current range. Voltage range. Integration period, displays the data refresh interval. Device info display, battery level, clock, communication status. System info, nameplate details, calculation formula, energy pulse constant. Settings, parameter settings, system settings, self-calibration. Power. Energy. Analysis. 4. Typical applications. 1. DC EV charger test. Use a dual-gun DC charging cable to connect the TK4710 DC resistive load to the TK4830. Connect the DC charger's gun head to TK4830. Use an Ethernet cable to connect TK4830 to a computer for communication. Connect the GPS module. To meet specific testing requirements, the device can also be used in a cascade configuration with DC loads. Connect the cascade charging port of the first load to the power supply port of the second load using a dual-gun charging cable. After the connection is completed, open the testing software on the computer. Click DC1 configuration. This section integrates the device, scheme, and parameters. Select device editing. Lower computer, enter the IP address, which can be obtained from TK4830 settings system settings IP. Control, default as computer. Type, select TE1200. Standardizer information, enter based on the standard device parameters. In load information mode, select resistance load or CAR. Choose the number of loads and the model, TE1310. Bluetooth communicator, check if the TP2000 environmental thermometer and the hygrometer is used. Scheme, you can choose to create a new plan or edit the default scheme. The default verification standard is selected as JJG1149 to 2022. Check the required test items. Visual inspection, items can be added or removed. Operate error test. 2 testing methods are available. Method 1, pulse method, conducts energy error testing by measuring the energy pulses from the charger under test. Configurable parameters per test point include number of error tests, error display digits, number of large errors elimination, set the voltage, current, number of pulses, and accumulated energy value of the test point. Method 2, accumulated energy method, tests energy error by displaying the standard cumulative energy value and comparing it with the cumulative energy from the charger under test. Configurable parameters per test point include number of error tests, error display digits. Add or delete multiple test points based on testing requirements. Each test point can be individually configured for voltage, current, and accumulated energy value. Charging mode, default is constant current mode. Clock indication error, select whether to display the date. The clock signal source defaults to the computer. Taking method 2 as an example, save the configuration. Parameter, enter the charger's parameter information. Charger type, select CCS, European standard. Fill in the parameters of the charger under test. You can also click Edit to customize parameter names. Calibration parameters, use the default settings. Verification environment, You can enter the current ambient temperature and the humidity, and the insulation resistance of the charger under test. Custom, users can complete other parameter information of the charger under test. Click Edit to add or remove items. Functions. During testing, you can click to view the real-time output waveform of the charger. Settings. Configure data storage path, printing, and software update settings. View the device connection status here. Note, this software is common to multiple devices. Some options and information do not need to be modified, using default setting is sufficient. For details, please refer to the device user manual. Start testing. You may choose to conduct a full item verification or a single item verification. Visual inspection. Check the appearance and functions of the charger under test against the verification items and record the results. Click Next to proceed to the Operate Error test. Follow the system prompts to swipe the card and activate the charger. Real-time data will be displayed at the top of the screen, while test progress and duration are shown below. Once the test is complete, the system will prompt you to read and record the electrical energy data from the charger before and after the test. Swipe the card to activate the charger again for a second round of testing. After both tests are completed, the system will automatically calculate the error values, average values, and determine whether the verification result is qualified. Clock indication error test. Click Stop Timing. The reference clock display time will automatically read the GPS time. The user should read the time displayed on the charger and enter it into charger display time. The system will automatically calculate the indication error and determine whether the verification result is compliant. Click Next. Result. Save test results. Click Data to view verification records and data. Select the desired data and click Print. Choose the required report template to generate the verification report. 2. AC EV charger test. Use an AC dual-gun charging cable to connect the TK4730 AC resistive load to the TK4830. Connect the AC charger gun head. Connect the device to a computer using an Ethernet cable. Connect the GPS module. Subsequent software configuration and testing operations are consistent with the steps described above.